Hey everyone, this problem is from the 2024 Euclid 4B. I thought this one was kind of interesting because there's a few routes you could kind of go down this one. The first one I tried was a bunch of trig equations. The second was a brute force algebra approach, and then the third was a very simple way that I thought was pretty cool. And so this problem says in the diagram, the line with the equation y equals negative 3x plus 6 crosses the x-axis at A and the y-axis at B. So A is right here, and then B's right here. So this line is negative 3x plus 6. Suppose that m is greater than 0, and the line with the equation y equals mx plus 1 crosses the y-axis at D. So this is going to be y equals mx plus 1. And it intersects the line with the equation y equals negative 3x plus 6 at the point C. So they intersect right here. And if O is origin and the area of ACD is 1/2 the area of ABO, so this triangle in here is half the area of this whole entire triangle ABO, then we have to determine the coordinates of C. So we're trying to find what this is. So the first thing I think I'll make a better sketch, or you know what, I can draw on top of this. Let's identify what we know. Let's try to draw some insight from what we know. So right now we have this y equals negative 3x plus 6. So the first thing that's good to do here is we can probably find the x and the y-intercept. So if we plug in 0 for x, we get 6 as our y value. And then if we say y is equal to 0, we subtract 6 from both sides. I'll just do that right now. Negative 6 equals negative 3x. And we get 2 is equal to x. So this right here would be 0, 6. And then this would be 2, 0. And then we also have one other piece of information. We have the y-intercept, because we can plug in x as 0, and it'll just basically, whatever m is, it'll just make it 0. So we know this point, D, is going to be 0, 1. And then what can we draw from the area? Well, since we know the base of this massive triangle is going to be 2, I mean, relatively massive compared to the other triangles, we know this is going to be 2 and this is going to be 6, and we can find the area of the whole entire triangle. The area of a triangle is equal to area equals 1/2 base times height. Area equals 1/2. We know our base is 2 and our height is 6. So the 1/2 and the 2 cancel out, so we're left with area equals 6. And what do we know now? Well, we found out here that ACD is 1/2 the area of ABO. What's 1/2 of 6? Well, 1/2 of 6 is just 3. And now we know CAD is 3. The area of that is 3. And then we can also find one more triangle, because we know DOA has coordinates 0, 1, and 2, 0, which means the height is going to be 1. The base is going to be 2. So we can use our area equation again and get area equals 1/2 base times height, substitute in our values, and we get area is equal to 1. And then we can solve for BCD just by knowing that the whole entire area is going to be equal to 3 plus 1 plus the BCD. And we can get from that BCD is equal to 2. BCD is equal to 2. We can put in 2 here, and then the great thing here is we can solve BCD. We can solve for the height of BCD, because we know a few values. Let me draw it out. We know, well, B to D is 6 to 1. B to D is 6 to 1, so it has a length of 5. And we also know the area is 2, so area equals 2. Well, how do we find the area of a triangle? Well, area is just equal to 1/2 base times height. We can assign the base anywhere, and we could just call maybe 5 our base, and then we need to find a height. This won't work as our height, neither will this. We need to find the height that goes from the very highest to the very lowest of the triangle, from the base to the highest point. So we need to find this, which just happens to be where our C value is located for the X value. Since we know the area is 2, and we know the base is 5, then we can solve for our height, which is actually going to be our x value. So if we multiply both sides by 2, we get 4 is equal to 5 times height, and we get height is equal to 4/5, which we know is actually just our x value of c. So we now know c, we'll just say x comma y. We know x is equal to 4/5, and now we can solve for y because they gave us an equation above, and we know c goes through that value. We know y is equal to negative 3x plus 6. Y is equal to negative 3x plus 6. We can plug in our x value, and we get y equals negative 3 times 4 over 5 plus 6. Negative 3 times 4 is just negative 12. And we get negative 12 over 5, and 6 times 5 is 30, and this is over 5, so then we have common denominators, and then we can do 30 minus 12, and that gives us 18 over 5. So our y value is equal to 18 over 5, so our coordinates thus are 4 over 5 and 18 over 5. And that's the solution. Thank you for watching.